I will discuss how to assign the oxidation number of an atom in a compound. The highlighted atom have unknown oxidation numbers. Let me start with first compound, that is K3FeO4. K is a potassium atom. It is a first A group element, and first A group element present in a compound, they always show +1 oxidation number. The usual oxidation number of oxygen atom is -2. Now we can do the calculation and find out the oxidation number of Fe. There are 3 potassium atoms. I put here 3 bracket. The oxidation number of potassium atom is +1. I put here +1 plus. There is only one Fe atom. I put Fe atom plus. There are 4 oxygen atoms. I put here 4 bracket. The oxidation number of oxygen atom is -2. Well, this is a neutral compound, means it does not carry any charge. Well, the total oxidation number of atoms of a neutral compound is always equal to 0 or always 0. That is why we equalize to 0. Now we can do the calculation. 3 1 3, we have +3 plus we have Fe atom, and so 4 2 8, we get -8 and equal to 0. +3 -8 is equal to -5. We have Fe -5 is equal to 0. We can transfer -5 on right side, we get Fe is equal to +5. Well, the oxidation number of Fe atom in this compound is +5. The next compound is given, that is Cr2 whole thrice of CO3. The usual oxidation number of carbon is obviously +4 and oxygen has -2 oxidation number. Now we can do the calculation to find out the oxidation number of Cr atom. There are 2 Cr atoms. I put here 2 Crs. There is a whole thrice of CO3. It means that there are 3 carbon atoms. I put here 3 bracket. The oxidation number of carbon atom is +4. I put here +4 plus 3 3 is 9. There are 9 oxygen atoms. I put here 9 bracket. The oxidation number of oxygen atom is -2. We put here -2. This is also a neutral compound. Well, the total oxidation number of atoms in a neutral compound is always 0. We equalize to 0. Now we do the calculation. We have 2 Crs, 3 4 is 12, we get +12, and 9 2 is 18, we get -18 is equal to 0. Here we have 2 Crs, 12 minus 18, we get -6 is equal to 0. We can transfer -6 on right side, we get 2 Crs is equal to +6. We can divide +6 by 2, 2 3 is 6, we have Crs is equal to +3. Well, the oxidation number of one Cr atom in this compound is +3. The next compound is Na2HPO4. Well, the oxidation number of phosphorus atom is unknown. Sodium atom is a first A group element in the periodic table, and the first A group element present in a compound, they always show +1 oxidation numbers. Well, hydrogen atom is combined with oxygen atom in this compound. If you draw the structures, phosphorus has a 5 valence electron, in which phosphorus is combined with 1 oxygen atom with through double bonds, and so we have 2 sodium atoms. Here we have ONA, ONA, and here we have, and the hydrogen atom is combined to oxygen atom. Well, if hydrogen atom is combined with a non-metal, it always shows +1 oxidation numbers. And if in case hydrogen atom is combined with a metal, it shows -1 oxidation number. For example, we can have sodium hydride, and say sodium is a metal, that is why hydrogen shows -1 oxidation number. And in case if it is combined with non-metal, that is oxygen, that is why it shows +1 oxidation number. Well, phosphorus has a non-oxidation number, and the usual oxidation number of oxygen atom is -2. Now we can do the calculation. Well, there are 2 sodium atoms. I put here 2 bracket. The oxidation number of sodium atom is +1. We put here +1 plus. There is only one hydrogen atom. I put here its oxidation number plus phosphorus atom, because its oxidation number is unknown, plus there are 4 oxygen atoms. I put here 4 bracket. The oxidation number of oxygen atom is -2. We put here -2. This is also a neutral compound. and the total oxidation number of atoms of this neutral compound is and will be 0. We can do the calculation. 2 1 2, we have plus 2 plus 1 plus phosphorus atom, 4 2 8, we get minus 8 is equal to 0, plus 2 and plus 1 make plus 3. We have phosphorus atom minus 8 is equal to 0, and plus 3 minus 8 is equal to minus 5 is equal to 0. Now we can transfer minus 5 on right side, we get phosphorus atom is equal to plus 5. Well, the oxidation number of phosphorus atom in this compound, neutral compound, is plus 5. The next compound is Fe whole twice of MnO4. Well, the Fe, the usual oxidation number of Fe is plus 2, it shows plus 2 oxidation numbers, and obviously oxygen has minus 2 oxidation numbers. Now we can do the calculation. There is only one Fe atom, I put its oxidation number plus 2, plus there is a whole twice of MnO4, it means that there are 2 Mn atoms, plus 4 2 8, there are 8 oxygen atoms, I put here 8 bracket, the oxidation number of oxygen atom is minus 2, this is also neutral compound, that is why we equalize to 0. Now we do the calculation. Plus 2 plus 2 Mn atom and 8 2 16 is equal to 0. And now we can do the calculation further. Plus 2 minus 16 is equal to minus 14. Here we have 2 Mn minus 14 is equal to 0. We can transfer minus 14 on right side, we get 2 Mn atoms is equal to plus 14. Now we can divide 14 by 2, 2 7 14, here we have Mn is equal to plus 7. Well, the oxidation number of Mn atom in this compound is plus 7. The next compound is HClO4. Cl has a unknown oxidation numbers. In this compound, hydrogen atom is combined with non-metal, that is why it shows plus 1 oxidation numbers, and oxygen of course has minus 2 oxidation number. Now we can do the calculation. There is only one hydrogen atom, I put its oxidation number plus 1, plus Cl atom, since its oxidation number is unknown, we put this atom itself here, plus there are 4 oxygen atoms, I put 4 bracket, the oxidation number of oxygen atom is minus 2, and this is also a neutral compound, that is why we equalize to 0. Here we have plus 1 plus Cl atom and 4 2 8, we get minus 8 is equal to 0, plus 1 minus 8 is equal to minus 7, Cl atom minus 7 is equal to 0. We can transfer minus 7 on right side, we get the Cl is equal to plus 7. Well, the oxidation number of Cl atom is plus 7 in this compound. Well, the next compound is H4P2O7. Hydrogen obviously has plus 1 oxidation number and oxygen has a minus 2 oxidation number. Now we can do the calculation. There are 4 hydrogen atoms, I put here 4 bracket, the oxidation number of hydrogen atom is plus 1, we put here plus 1, and there are 2 phosphorus atoms, I put here 2p, plus there are 7 oxygen atoms, I put here 7. Well, the oxidation number of oxygen atom is minus 2, we put here minus 2. This is also a neutral compound, that is why we just equalize to 0. Now we do the calculation further. We have plus 4 plus 2 phosphorus atom and 7 to the 14, we get minus 14 is equal to 0. Plus 4 minus 14 is equal to minus 10. Here we have 2p minus 10 is equal to 0. We can transfer minus 10 on right side, we get 2 phosphorus atoms is equal to plus 10. You can divide plus 10 by 2, 2 5 ja 10, we get phosphorus atom is equal to plus 5. Well, the oxidation number of phosphorus atom in this compound is plus 5. The next compound, it is polyatomic ion. Polyatomic ion is an ion which is made up of more than 2 atoms. Its total charge is minus 2. Well, oxygen has minus 2 oxidation numbers and the Mn has unknown oxidation numbers. I put here Mn atom, plus there are 4 oxygen atoms, I put here 4 bracket, the oxidation number of oxygen is minus 2, we put here minus 2. Well, this is a polyatomic ion. and the total oxidation number of atoms in a polyatomic ion is always equal to its total charge. It has -2 total charge, that is why we equalize to -2. Now we can do the calculation. Mn 4 2 ja 8, we get -8 is equal to -2. We can transfer -8 on right side, we get Mn atom is equal to -2, we have +8, and -2 plus 8 is equal to +6. Mn is equal to +6. Well, the oxidation number of Mn is +6 in this polyatomic ion. Well, the next compound is hydrogen peroxide, and hydrogen is combined with oxygen atom, that is non-metal, that is why it shows +1 oxidation numbers. Now we can do the calculation. There are 2 hydrogen atoms, I put here 2 bracket, the oxidation number of hydrogen is +1, plus there are 2 oxygen atoms, I put here 2O, and this is also a neutral compound. This is a neutral compound, we equalize to 0. The total oxidation number of atoms we equalize to 0. Well, here we have +2 and say 2 oxygen atoms is equal to 0. We can transfer 2 on right side, we get 2 oxygen atoms is equal to -2. You can divide 2, 1 is 2, here we have oxygen atoms is equal to -1. Well, the oxidation number of oxygen atom in this peroxide compounds is -1. Well, the usual oxidation number of oxygen atom we always use, that is -2. But there is one exception. If oxygen atom is present in a peroxide, it always shows -1 oxidation number. You can see in barium peroxide, it also shows -1 oxidation number, but the usual oxidation number of oxygen atom is -2 in most of the compounds. The next compound is, that is Fe and whole thrice of NO3, and nitrogen atom is present a 5th A group, and its and oxidation number is 5. Oxygen has obviously -2 oxidation number. Now we can do the calculation. There is only one Fe atom, I put here Fe atom, plus there is a whole thrice of NO3, it means that there are 3 nitrogen atoms, I put here 3 bracket. The oxidation number of nitrogen is +5, we put here +5, and plus 3 3 are 9, there are 9 oxygen atoms, I put here 9 bracket. The oxidation number of oxygen is -2, and this is also a neutral compound, we equalize to 0. Now we do the calculation further, plus 3 5 are 15, 9 2 are 18, we get -18 is equal to 0, and say Fe, and plus 15 minus 18 is equal to, we have -3 is equal to 0. We can transfer -3 on right side, we get Fe atom is equal to +3. Well, the oxidation number of Fe atom in this compound is +3. The next compound is Ag2CrO4. Ag means it is a silver atom, and the silver atom, it has a usual oxidation number. In general, we use +1 oxidation number for silver atom. Well, and obviously oxygen has a -2 oxidation number. Now we can do the calculation. There are 2 silver atoms, I put here 2 bracket. The oxidation number of oxygen atom is oxidation number of silver atom Ag is +1, and plus there is only one Cr atom, I put here Cr atom, plus there are 4 oxygen atoms, I put here 4 bracket. The oxidation number of oxygen atom is -2, we put here -2, and this is also a neutral compound, it does not carry any charge, that is why we equalize to 0. Now we do the calculation. 2 1 are 2, we get +2, plus Cr 4 2 are 8, we get -8 is equal to 0. +2 minus 8 is equal to -6. Cr -6 is equal to 0. We can transfer -6 on right side. Cr is equal to, we have +6. Well, the oxidation number of Cr atom in this compound is +6. The next, it is also a polyatomic ion. It is a polyatomic ion because it is made up of more than 2 atoms, and it carries charge. And the usual oxidation number of oxygen atom is -2. We can do the calculation. There are 4 boron atoms. I put here 4 boron atoms. Plus there are 7 oxygen atoms. I put here 7. And well, the oxidation number of oxygen atom is -2. This is a polyatomic ion, and the total oxidation number of atoms in a polyatomic ion is always equal to its total charge, and its total charge is -2, equalize to minus 2. Now we do the calculation. 4 boron atoms and 7 to the 14, we get minus 14 is equal to minus 2. We can transfer minus 14 on right side. 4b is equal to, we get minus 2 plus 14. Here we have minus 2 plus 14 is equal to plus 12. We get 4 boron atoms. You can divide it plus 12 by 4. 4 3 ja 12. Boron atom is equal to plus 3. In this polyatomic ion, the oxidation number of boron atom is plus 3. The next compound is calcium sulfate. Calcium is a second A group element in the periodic table, and second A group element present in a compound, they always show plus 2 oxidation numbers. Obviously, oxygen has minus 2 oxidation number. Now we can do the calculation to find out the oxidation number of sulfur atom. There is only one calcium atom, I put its oxidation number plus 2, and there is only one sulfur atom, I put sulfur atom itself here, plus there are 4 oxygen atoms, I put here 4 bracket. The oxidation number of oxygen is minus 2, we put here minus 2. This is also this is a neutral compound. This is a neutral compound, V equals to 0. Here we have plus 2 plus sulfur atom, and 4 to the 8, we get minus 8 is equal to 0, and say plus 2 minus 8 is equal to minus 6. Sulfur atom we get minus 6 is equal to 0, and say we can transfer minus 6 on right side is equal to, we get plus 6. Well, the oxidation number of sulfur atom in this compound is plus 6. Well, the next compound is sulfuric acid and H2SO4. The usual oxidation number of hydrogen is plus 1, because it is combined with non-metal oxygen, and sulfur has a non-oxidation number, and oxygen has obviously minus 2 oxidation number. Now we can do the calculation. There are 2 hydrogen atoms, I put here 2 bracket. The oxidation number of hydrogen atom is plus 1, we put here plus 1, plus, and sulfur has a known oxidation number, plus there are 4 oxygen atoms, I put here 4 bracket. The oxidation number of oxygen atom is minus 2, and this is a neutral compound, we equalize to 0. Now here we have plus 2 plus sulfur atom, 4 to the 8, we equalize to 0, plus 2 minus 8 is equal to minus 6, s minus 6 is equal to 0, and we can transfer minus 6 on right side, s is equal to plus 6. Well, the oxidation number of sulfur atom is plus 6 in sulfuric acid. The next is polyatomic ion, and oxygen of course has minus 2 oxidation numbers. Now there are 2 sulfur atoms, I put here 2 sulfur atoms, plus there are 3 oxygen atoms, I put here 3 bracket. The oxidation number of oxygen atom is minus 2, we put here minus 2, and this is a polyatomic ion, and the total oxidation number of atoms in a polyatomic ion is always equal to its total charge. It has total charge minus 2, we equalize to minus 2. Now we can do the calculation. 2 sulfur atoms plus 3 to the 6, we get minus 6 is equal to minus 2. We can transfer minus 6 on right side, we get a 2 sulfur atoms is equal to minus 2 plus 6. Here we have plus 4, on left side we have 2 sulfur atoms. So we can divide 4 by 2, 2 to the 4, sulfur atom is equal to plus 2. Well, the oxidation number of sulfur atom in this polyatomic ion is plus 2. Well, next is sodium atom. Sodium, it is a neutral atom, it is in uncombined state, and the oxidation number of a neutral atom is always 0, Cl2. Next is Cl2. It is a molecule, it is made up of same type of atoms, only Cl atoms, and the oxidation number of a molecule which is made up of same type of atoms is always 0. We can assign 0 oxidation number. Same case goes with ozone. It is made up of only oxygen atoms, so that is why it has 0 oxidation number, and similarly acid also has 0 oxidation numbers. Well, these are the ions are given here. Sodium ion. Well, the oxidation number of an ion is always equal to its total charge. It has plus 1 charge, that is why its oxidation number will be plus 1. Aluminum has plus 3 charge, that is why its oxidation number will be plus 3. And sulfide ion has a minus 2 charge, that is why its oxidation numbers will be equal to its charge, and similarly oxide ion will also have total oxidation numbers minus 2 equal to its total charge. and so these are polyatomic ions are given here, and so same concept applies with polyatomic ions also. The oxidation number of atoms of polyatomic ion is always equal to its total charge. SO3 has total charge -2, that is why its oxidation numbers, total oxidation number will be -2. Similarly, it has also -2 total oxidation number, and says the ClO3 it has a total charge -1, that is why its total oxidation number will be -1. This is how we can assign the oxidation number of atoms in a compound.